Hello everyone. Today we will start part 7 of the chapter Polynomials, class 9 standard. In the last part we discussed two different methods to factorize the polynomials. First one by splitting the middle term and second by factor theorem. So now we will start exercise 2.4 which is based on these concepts only. So let's see question number 1. Question number 1 is determine which of the following polynomials has x plus 1 a factor. First part is x cube plus x square plus x plus 1. So we have considered let px is equals to x cube plus x square plus x plus 1. Now we have to find out whether this polynomial has x plus 1 a factor. Right. For this, what we will do, whenever we have to find out that any linear polynomial is a factor of the given polynomial, first we will find out the 0 of the polynomial. So x plus 1 we have. How to find out the 0 of the linear polynomial? We have to put that linear polynomial equals to 0. So x plus 1 is equals to 0. So what is the value of x? X is equals to minus 1. So what is the 0 of the polynomial x plus 1? Minus 1. So for x plus 1 to be factor of px, when we will put the value of x in px, it should be 0. That means when we will put minus 1 in the polynomial px, its value should be equals to 0. If it is 0, that means x plus 1 is a factor of px, otherwise not. So we have find out the 0 of the linear polynomial. Now what we will do? We will put x is equals to minus 1 in px. Why we are putting minus 1? Because minus 1 is the 0 of the given linear polynomial. So p minus 1 is equals to minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. And when we will solve, we are getting 0. That means p minus 1 is equals to 0. P minus 1 means when we are putting x is equals to minus 1 in px, we are getting p minus 1. And after calculating, its value is equals to 0. That means x plus 1 is a factor of the given polynomial px. Now same way we will do second part. Now second part, px is equals to x raised to power 4 plus x cube plus x square plus x plus 1. Now for this polynomial also, we have to find out whether x plus 1 is a factor of this px or not. So again we will find out the 0 of x plus 1. It is same only minus 1. So what we will do? We will put x is equals to minus 1 in this new polynomial px. So p minus 1 is equals to minus 1 raised to power 4 plus minus 1 raised to power 3 plus minus 1 whole square plus minus 1 plus 1. And after solving, we are getting 1. And this 1 is not equals to 0. So p minus 1 not equals to 0. And when it is not equals to 0, it means x plus 1 is not a factor of the given polynomial px. Now let's see third part. Third part, px is equals to x raised to power 4 plus 3x cube plus 3x square plus x plus 1. Again question is same. We have to find out whether x plus 1 is a factor of this polynomial px or not. Now again the 0 of x plus 1 is minus 1 only. So what we will do? We will put x is equals to minus 1 in the px. So p minus 1 is equals to minus 1 raised to power 4 plus 3 into minus 1 raised to power cube plus 3 into minus 1 whole square plus minus 1 and plus 1. And after solving, we are getting 1. That is not equals to 0. That means p minus 1 not equals to 0. And it is not equals to 0. It means x plus 1 is not a factor of the given polynomial px. Right? Whenever we are putting the value of the 0 in the polynomial, if it is equals to 0, that means that is a factor. If it is not equals to 0, that means it is not a factor. Now fourth part, px is equals to x cube minus x square minus 2 plus under root 2 into x plus under root 2. Now again same, we have to find out whether x plus 1 is a factor of this polynomial px or not. So we will first find out the 0, that is minus 1 only. What we will do? We will put x is equals to minus 1 in px. So we will get p minus 1 is equals to minus 1 whole cube minus minus 1 whole square minus 2 plus under root 2 into minus 1 plus under root 2. And after solving, we are getting 2 under root 2. And again, this is not equals to 0. That means p minus 1 not equals to 0. That means x plus 1 is not a factor of the given polynomial px. Now let's do question number 2. Question number 2 is use the factor theorem to determine whether gx is a factor of px in each of the following cases. The first part is px is equals to 2x cubed plus x square minus 2x minus 1 and gx is equals to x plus 1. So we have to find out whether x plus 1 is a factor of the polynomial px, right? So here px is this and gx is x plus 1. Now it's same only. We have to find out whether x plus 1 is a factor of px or not. So what we will do, we will find out the 0 of x plus 1. So 0 of x plus 1 is minus 1. So we will put minus 1 in px and it should be equals to 0. So put x equals to minus 1. P minus 1 is equals to 2 into minus 1 whole cube plus minus 1 whole square minus 2 into minus 1 and minus 1. After solving, we are getting 0. That means p minus 1 is equals to 0. When it is 0, that means by the factor theorem, gx is a factor of the given polynomial px. Okay, and this also we have to do the same only to find out whether the given polynomial is a factor of the given polynomial px or not. We will first find out the 0 of that, and that value of 0 we will put in px. After putting the value in px, if we are getting px is equals to 0, that means the given polynomial is a factor of px, and if it is not equals to 0, that means it is not a factor. Now let's see second part. Px is equals to x cube plus 3x square plus 3x plus 1 and gx is equals to x plus 2. So we have written here px and gx. Now what is the 0 of gx? X plus 2 is equals to 0 we will put. So we will get x is equals to minus 2. So here p minus 2 should be equals to 0. So we will put x is equals to minus 2 in px. So p minus 2 is equals to minus 2 whole cube plus 3 into minus 2 whole square plus 3 into minus 2 plus 1. And after solving it, we are getting minus 1, which is not equals to 0. That means by the factor theorem, gx is not the factor of the given polynomial. Now let's do third part. Px is equals to x cube minus 4x square plus x plus 6 and gx is equals to x minus 3. We have to find out whether gx, that is x minus 3, is a factor of px or not. So for this what we will do, we will find out the 0 of gx. So x minus 3 we will put equals to 0. So we will get x is equals to 3. So we have written here px and gx. We will put p minus 3, and if it is 0, that means it is a factor of px, otherwise not, right? So put x is equals to 3 in px. P3 is equals to 3 cube minus 4 into 3 square plus 3 plus 6. And after solving, we are getting 0. That means P3 is equals to 0. And when it is 0, that means by the factor theorem, gx is the factor of the given polynomial px. Now let's see question number 3. Question number 3 is find the value of k if x minus 1 is a factor of px in each of the following cases, right? So basically what we have to do in this question, polynomial px is given and it is given that x minus 1 is a factor. In the last question we were finding whether the linear polynomial is a factor of px or not, but in this question it is written that it is a factor of px, right? But we have to find out the value of k. So let's see first part. Polynomial px is equals to x square plus x plus k, and it is written that x minus 1 is a factor of px, right? Now rule is same only. For any linear polynomial to be a factor of px, first we will find out the 0 of the polynomial, and that 0 we will put in px and it should be equals to 0. So here linear polynomial is x minus 1, right? So what is the 0 of x minus 1? X minus 1 is equals to 0, so we will get x is equals to 1. So what we will do, we will put x is equals to 1 in Px and its value should be equals to 0, right? So by factor theorem, P1 should be equals to 0. And it is given it is a factor, that means P1 is equals to 0. So we will put x is equals to 1 in Px. So P1 is equals to 1 cube plus 1 plus k, and it is equals to 0 because in the question it is given that x minus 1 is a factor of Px. So when we will solve, we will get 1 plus 1 plus k is equals to 0. That means k is equals to minus 2. So by the factor theorem, we have find out the value of k, and that is equals to minus 2. Now let's see second part. In second part, px is equals to 2x square plus kx plus under root 2. And again, x minus 1 is a factor of px. It is already given. So what is the 0 of x minus 1? X is equals to 1. So we will put p1, and the factor theorem p1 is equals to 0. So P1 is equals to 2 into 1 square plus k into 1 plus under root 2, and that is equals to 0. So it is 2 plus k plus under root 2 is equals to 0. Now constant terms, constant k we will write separately. 2 plus under root 2 plus k is equals to 0, and it will be k is equals to minus 2 plus under root 2. That means we have find out the value of k, that is k is equals to minus 2 plus under root 2 by using the factor theorem. Now let's do third part. Px is equals to kx square minus under root 2x plus 1. Right. So px is given and x minus 1 is a factor of px. It is already given. And we have to find out the value of k. So x minus 1 is a factor of px. That means when we will put x is equals to 1, it is equals to 0. So x minus 1 is a factor of px. Then by factor theorem, p1 is equals to 0. So put x is equals to 1 in px. We will get p1 is equals to k into 1 square minus under root 2 into 1 plus 1, and that is equals to 0. And when we will solve, we are getting k is equals to under root 2 minus 1. That means the value of k is under root 2 minus 1 by factor theorem. Now fourth part, px is equals to kx square minus 3x plus k, and x minus 1 is the factor of px, it is given. So again, x minus 1 is a factor of px. Then by factor theorem, p1 is equals to 0. So we will put x is equals to 1 in px. So p1 is equals to k into 1 square minus 3 into 1 plus k is equals to 0. And after solving, we are getting k is equals to 3 upon 2. That means value of k is 3 upon 2 by factor theorem.